So, Chapter 7 is all about the subset of linear programming, which is the integer linear programming. So, on my part, I will discuss the three different types of integer linear programming models, including the formulation, graphical, and computer solutions for an all integer linear programming. And the second part of this discussion talks about the applications involving 0-1 variables, specifically capital budgeting, fixed cost, distribution system design, bank location, and market share optimization problems. This also includes the modeling flexibility provided by 0-1 integer variables. So, first, let us define what integer linear programming is. So, problems that are modeled as linear programs with additional requirement that one or more variables must be an integer. So, basically, integer are those any number that is not a fraction or a decimal. Integer can also be in a form of positive or negative numbers. However, negative numbers will not be applicable in getting the solution points because we are considering the non-negativity constraint as what we have learned in chapter 2. So it is harder to solve that linear programming problems. One should not try to solve a problem as an integer program if simply rounding the linear programming solution is adequate. So it is harder to solve because in problems such as determining how many cars to manufacture, how many houses to purchase, requires further analysis. You cannot purchase a car, you cannot purchase a house in fractional or in decimal number. On the other hand, rounding off of amounts can produce an extra economic consequence, making it a not more realistic one. So this is not like a linear programming problem such as those discussed in previous chapters that rounding off has a little economic consequence on the objective function and feasibility is not an issue. Again, studying integer linear programming is important because it is very helpful when fractional values of the variables are not permitted, and rounding off a linear programming solution may not provide an optimal integer solution. So, let us differentiate the what integer linear programming and linear programming is. So, integer linear programming is a subset of linear programming, and it has all the characteristics of linear programming except the solution to the linear programming must be restricted to integers. While linear programming is an attempt to find a maximum or minimum solution to a function given a certain constraint. So, integer linear programming is like a linear programming where it has objective and constraints. So, ang integer linear programming naasad na siya objective, naasad na siya mga restrictions or mga constraints. So, pero sa integer linear programming, required siya that the solution must be an integer. That is the only difference, and when we talk about the process, same Japon silang duha sa process. So, here is the graph presenting to you in finding the optimal solution in integer linear programming. Dapat diri sa mga dots, kaning mga dots, mga dots, dapat matungod ang ato ang optimal solution because again, it should be a whole number, it should be an integer. So, dapat dili siya mo ang atong optimal solution, dapat dili siya mo dili siya matungod aning mga white, dapat ana siya sa blue para whole number siya, para integer siya. So if ever in a form of decimal jud na siya, then we need to wiggle around until we reach the best integer solution, which is again represented by the blue dots. So if it's a linear programming, so okay ra siya dili matunong sa mga blue dots. Okay ra sad siya matunong. Meaning it can be in decimal form, it can also be in a whole number ang integer ay ang linear programming model. So here presenting to you the types of integer linear programming models. First, we have the all integer linear program, the mixed integer linear program, and the 0-1 linear integer program. So first, let's talk about the all integer linear program. So all variables are required to be an integer in this type of integer program. So provided here, the mathematical model, and to express nga ang ato ang all integer linear program nga, to express nga ang ato ang all variables kay integer, we will drop here the kaning and integer. So kana siya, the feasible solution will deals only to the points where both x and y are integers simultaneously. So sa atong feasible solution for this all integer linear program is diri ra siya sa mga dots kaning dire. Nara dira ang ato ang feasible solution sa mga collection of dots. And here our optimal solution is the in all integer program is naa diri sa 0, 0, 4, or ato ang value sa ato ang x ay ato ang value sa ato ang we have x is 0 and our y is equal to 4. So assume. Now, let us suppose that we will ignore the integer requirements. So, for instance, we will ignore that all variables will be integer. So, here, we will have our optimal solution of x. Here, x, our optimal solution is x is equal to 1.59 and y is equal to 2.76. So, ari na point, ato in decimal na siya, kay lagi atong gi-ignore ang requirement nga dapat all ang variables kay dapat all integer. So, mana siya. So, the process is what we call the LP relaxation. So, sa book, it was being written in there that the linear program that results from dropping the integer requirements is called the LP relaxation of the integer linear program. So, ang LP relaxation di ay kay it is the process where we begin with the integer problem and later ato asyang gi-ignore and later we ignore the integer requirements when finding solution to the problem. So as a result, for integer linear programs involving maximization ng mga problems, the value of optimal solution to the LP relaxation provides an upper bound on the value of the optimal integer solution. And for integer linear programs involving minimization problems, the value of optimal solution to the LP relaxation provides a lower bound on the value of the optimal integer solution. So here, the next type of a integer linear programming is the mixed integer linear program. So, wala ko nagsunod, wala na ko gi-copy ang example sa book kay wala siya graph nga gi-provide. Nangita ko glain og example nga naay graph kay para dali ra nato masabtan kung unsay differences ani nilang tulo. tulo ka types. So again, balik ta sa mixed integer linear program, some but not necessarily all variables are required to be an integer. So to express this mixed integer linear program, we put here and x integer, because only x are now needed to be an integer. So in mixed integer linear program, na ay specific variable kung asay dapat na integer, because again, some but not necessarily all variables are required to be integer. So ari diri na part, ang x, values of x dapat integer. So kani integer. So thus, our feasible solutions are set of vertical lines. Kanina adiri ang ato ang vertical, nadira ang ato ang feasible solution. So here, our optimal solution will be x is equal to 1 and y is equal to 3.2. So as what I've said, ang ato ang gipangita dire, kani, atong constraint man sa tawag ana, nga x dapat integer. So here, wala siya dira nga ato ang x kay integer siya, dayon ang y is dili siya integer kay some but not necessarily all. So gimix siya og integer, whole number og in decimal, or pwede sad siya in fraction. Next is if ang y na sad ang needed nga dapat i-integer, so we will put in the model nga and y integer. So integer. So thus our optimal solution are set of horizontal lines. Kani mga horizontal lines kay y baya y. So specifically, our optimal solution will be x is equal to 1.25 and y is equal to 3. So since y man dapat ang integer diri, mo na siya ang ato ang y dinha mao ang whole number. So integer variables may only take on the variables, Kanday. The third type of integer linear programming is the 0-1 integer linear program. So integer variables may only take on the values 0 or 1. It is a mathematical method of using a series of binary yes kung 1 and no kung 0 answers to arrive at the solution when there are two mutually exclusive options. So assigning a simple yes or no value can be a powerful way to establish a linear problem-solving framework to identify inefficiencies. These can be helpful for companies that are unsure about specific business decisions and are looking for a straightforward way to assess the possibilities. So this type of linear integer programming will be further discussed in the part 2 of this discussion. So to siya, part 2 of this discussion. Ato siya i-discuss. So next is the graphical and computer solutions for an all-integer linear programming. So just like the process done in linear programming, so as what I've said earlier nga ang linear programming ay ang integer linear programming is the same process with the linear programming. So first, we need to understand the problem thoroughly, define the decision variables. Next is to formulate the objective function, formulate also the constraints, and then create the mathematical model. And then the sixth one would be the creation of graphical solution. So first, we need to understand the problem thoroughly. So mano siya. Eastbourne Realty has 2 million variable for the purchase of new rental property. After an initial screening, Eastbourne reduced the investment alternatives to town houses and apartment buildings. Each townhouse can be purchased for $282,000 and 5 are available. Each apartment building can be purchased for $400,000 and the developer will construct as many buildings as Eastbourne wants to purchase. Eastbourne property manager can devote up to 140 hours per month to these new properties. Each townhouse is expected to require 4 hours per month, and each apartment building is expected to require 40 hours per month. So the annual cash flow after deducting the mortgage payments and operating expenses is estimated to be $10,000 per townhouse and $15 per apartment building. Eastbourne owner would like to determine the number of townhouses and the number of apartment buildings to purchase the maximize annual cash flow. So, the butang to no, so manata og understand sa tong problem, manata agreed. Next step is to define the decision variables. So in defining the decision variables, we let T as the number of townhouses to purchase, and we let A as the number of apartment buildings to purchase. Next step is to formulate the objective function, and our objective function here is the maximum of 10T plus 15A. So ang 10 nato, ang kani nga 10 dire, it is the estimated annual cash flows after deducting the mortgage payment and operating expenses of townhouses. And our 15 here is also the estimated annual cash flows after deducting the mortgage payment and operating expenses of apartment building. Nya, ang kaning T and A dire, of course, the number of townhouses to purchase, and A as the number of apartment building to purchase. So again, our objective is to determine the number of townhouses and the number of apartment to purchase to maximize annual flows. So next is we need to formulate our constraints. So our constraints includes 282A2T plus 400A is less than or equal to 2,000. So it is the constraints of funds available. It is the funds available constraints. So ang kanang 282 nato diray, kanang 282, it is the amount. It is the amount to purchase townhouse, and our 400 here is the amount to purchase an apartment building, and our 2,000 is the available amount to purchase a new property. Next, our constraint is the manager's time. So 4 here represents kanang 4 din ha, nagrepresent na siya sa required hours of townhouse. And then the 40 naguna siya, and then the 40 represents the required hours for the apartment building, and then the 140 there is the devoted hours per month. So naatay 40 plus 40A less than or equal to 140, and we have also the last constraint, which is the T plus less than or equal to 5 townhouses available. So kanang 5, it is the available townhouses that can be purchased. So katong 5 ra. So walay value ang A because ang A kay nakabutang dito that the siya na gibutang dito sa problem nga and the developer will construct as many buildings as Eastbourne wants to purchase. So bisag pila ra, so matuwala siya butang dira, so ara dira infinity. So the next step is to the next step is to have a mathematical model. So mo na siya ato rang gi-combine ang ato ang objective function and our constraint additional the non-negativity constraint. So na siya t and a is greater than or equal to 0 and integer. So kani unsa ganito ang word diri nga kani nga gani phrase and integer nagpasabot that all variables are integer. So ato ang gi-solve diri is an all it is an all integer linear program. So next is to have our graphical solution. So in isa dire. So dire same as in linear programming, we need to substitute the values of t and a into zeros to get the respective solution points. Here are the solution points that will be used in creating our graphical solution. So mo na siya na solve na kato ra siya gi-substitute into 0. So there will be provided no solution process on how I arrived on that following points because I know that you know kung giunsa na siya pag-solve. So now we need to plot the solution points. So first is the available funds constraints. So here available funds constraints, and then next constraint is the manager time constraint, and the last one is the townhouses available constraint. So for me it is a positive infinity because infinity na siya because the value of a is a positive infinity again since it was stated in the problem that the developer will construct as many building that Eastbourne wants to purchase. So it is also a positive infinity because we need to consider our non-negativity constraint. So mo na siya. Here is the figure 7.1 again, graphical solution to an LP relaxation of the Eastbourne reality problem. So we have here the optimal solution of t is equal to 2.479 and a is equal to 3.252. So thus the optimal solution of the objective function is 73.574, which indicates the annual cash flow of 73,574. So unfortunately, Eastbourne cannot purchase fractional numbers of townhouses and apartment buildings. So again, as what I have mentioned earlier, that these instances needs further analysis. So rounding to obtain an integer solution. So in many cases, a non-integer solution can be rounded to obtain an acceptable integer solution. So katong sa ato ang linear programming problems, acceptable ang pag-round off nato dito. So for instance, a linear programming solution to a production scheduling problem might call for the production of 15,132.4 cases for breakfast cereal, and the rounded integer solution of 15,132 cases would probably have a minimal impact on the value of the objective function and the feasibility of the solution. So when the decision variables take into small values that have a major impact in the value of the objective function or feasibility, an optimal integer solution is needed. So here, in this scenario, we can say that the rounding off would be a sensible approach, and it is not always a good strategy para sa born katong company. So here, rounding to obtain an integer solution. So here, our optimal solution is t is equal to 2.479 and a is equal to 3.252. Note that the townhouse cost $282,000 and apartment building costs $400,000. These both costs has a major impact on the value of the objective function. Kay bisag usa lang ka apartment or townhouse ang nawala or mapuno tungod sa pag-round off nato, it will cost na 282,000 or 400,000 na dollars na effect kung again na ay kuan bisag usa lang ang maapektuhan gani sa atong pag-round off, mapun-an baron or makwangan. So bugat kayo kay dako kayo ang value. So now let us suppose that the value of t will be ato siyang i-round off kani. Suppose nga kani ato siyang i-round off niya. To ang pag-round off ni result og t is equal to 2 and a is equal to 3. So provided the objective function, we need to substitute the value of t, which is 2, and substitute also the value of a, which is 3. So dira we arrived at $65,000. So $65,000 is less than $73,574. Next, let us suppose that sa ato ang pag-round off ni result og 3 ang t unya 3 ang a. So given the objective function, we need to substitute the value of t, which is 3, and a, which is 3. So we arrived at 75,000. So $75,000 is greater than $73,574. And then next, we suppose nga ato ang pag-round off again ni result into 2 sa t and ni result og 4 sa a. So given the objective function, substitute the value of t, which is 2, the value of a, which is 4. So we get the $80,000, and $80,000 is greater than 73,574. So these two nga ato ang trial and error are infeasible because it requires more funds that $200 million Eastbourne has available. However, this atong pag-trial and error, at that point, we consider this as the best feasible integer solution. Basically, nasud man ang 65,000 sa feasible region. Pero wala pa ta kabalo asa jud ang best integer solution sa problem kung ano na siya best feasible integer solution. Pero wala ta kabaw sa best integer solution unsa jud pinaka best. Rounding to an integer solution is a trial and error approach. Again, katong gibuhat nato ganina, trial and error approach. Each rounded solution must be evaluated for feasibility as well as for its impact on the value of the objective function, even in the cases where a rounded solution is feasible. We do not have a guarantee that we have found the optimal integer solution. So presenting you again the figure 7.1, the graphical solution to the LP relaxation of the Eastbourne realty problem, and we can see here that our optimal LP realization solution is in decimal form. So kana siya in decimal. And since optimal solution must have an integer value, we can identify the feasible integer solution with these dots. So kani with these dots. So atong i-move ang objective function line to the nearest feasible integer point. So the dots represents the feasible integer point. So the best feasible integer point in this graph is that the T is equal to 4 and A is equal to 2. So we will get the, nato siyang i-substitute, we will get the annual cash flow of $70,000. So provided here the data we obtained ganina sa pag-round off and the data we obtained considering the dots provided in 7.2. So nakita nato nga ang 70,000 is much better considering the given objective function kaysa sa $65,000. Thus, we conclude that rounding off would not have been the best strategy for Eastbone Realty. So, ano siya? This is dili siya maayo na strategy para sa Katona Company. Next here, presenting to you, all of you, the computer solution. So, Lingo or Frontline System Solver can be used to solve most of the integer program in this chapter. So, here, given the variable t and a, the value of t, kay, diba, 4 man to sa optimal solution, we have specifying both t and a sa figure, that t and a as integers provides the optimal integer solution shown in figure 7.3. The solution of t is equal to 4 townhouses and a is equal to 2 apartment building has a maximum annual cash flow of $70,000. So the values of the stock variable tell us that the optimal solution has a 72 of available funds unused, and there will be 44 hours of manager's time still available, and then there is a 1 available townhouses not purchased.